Welcome back to our ongoing lesson on form factors, power supplies, and working inside the computer. Now, before we just jump right into the computer, it's important that you protect yourself and the equipment against electrical dangers. In this part of the chapter, you'll learn about the physical dangers of supporting personal computers and how to protect yourself and others. Then you'll learn about what can happen to damage a computer or other equipment while you're working on it, and what to do to prevent that damage. And as you work with computers, to stay safe and protect the equipment, always make it a habit to apply all the safety precautions that we discuss here. You need to protect yourself against electrical shock and burns. To protect yourself against electrical shock when working with any electrical device, including computers, printers, scanners, and network devices, disconnect the power. If you notice a dangerous situation that might lead to electrical shock or fire, please disconnect your power. And then, when you disconnect the power, do so by pulling on the plug at the AC outlet. Don't grab hold of the cord and just yank. To protect the power cord, don't pull on the cord itself. Also, don't just turn off the on-off switch on the device. You need to actually disconnect the power. And note that any of the following can indicate a potential danger. The power cord is frayed or otherwise damaged in any way. Water or other liquid is on the floor around the device or spilled on it. The device has been exposed to excess moisture. The device has been dropped, or you notice physical damage. You smell a strong electronics odor. The power supply or fans are making a whining noise. You notice smoke coming from the computer case, or the case feels unusually warm. When working on the inside of computers, printers, and other electrical devices, remove your jewelry that might come in contact with the components. Jewelry is made of metal and might contact electricity if it touches a component. Power supplies and CRT monitors, the old-fashioned monitors, that have a large case with a picture tube, contain capacitors. Now, a capacitor holds its charge even after the power is turned off and the device is unplugged. A ground is the easiest possible path for electricity to follow. If you are grounded and touch a charged capacitor, its charge can flow through you to the ground, which can shock you or kill you. Therefore, if you ever work inside one of these devices, be careful that you are not grounded. Later in this chapter, you will learn that being grounded while working on sensitive low-voltage electronic equipment such as a motherboard or processor is a good thing. And the best way to ground yourself is to wear an anti-static grounding bracelet connected to the ground. However, when working on a CRT monitor, power supply, or laser printer, don't wear the anti-static bracelet because you don't want to be the ground for these high-voltage devices. Now, how to work inside a power supply or CRT monitor is not covered in this lesson, and is not considered a skill needed by an A+ certified support technician. The power supply and monitor are both considered to be a field replaceable unit. That means, as a support tech, you're expected to know how to replace one when it breaks, but not how to repair one. So let's talk about protecting the equipment against static electricity, or ESD, electrostatic discharge. Now, suppose you come indoors on a cold day. Pick up a comb and touch your hair. Sparks fly. What happened? Static electricity caused the sparks. Electrostatic discharge, ESD, commonly known as static electricity, is an electrical charge at rest. When you came indoors, this charge built up in your hair and had no place to go. An ungrounded conductor, such as a wire that is not touching another wire, or a non-conductive surface, such as your hair, holds a charge until the charge is released. When two objects with dissimilar electrical charges touch, electricity passes between them until the dissimilar charges become equal. To see static charges equalizing, turn off the lights in the room. Scuff your feet on the carpet and touch another person, or personally I prefer to touch my cat's nose. Okay. Occasionally you can see and feel the charge in your fingers. And if you can feel the charge, you discharge at least 1500 volts of static electricity. If you hear the discharge, you released at least 6,000 volts. And if you can see the discharge, you released at least 8,000 volts of electrostatic discharge. Now, a charge of only 10 volts can damage electronic components. You can touch a chip on the expansion card or a motherboard, damage the chip with ESD, and never even feel, hear, or even see the discharge. ESD can cause two types of damage in an electronic component: catastrophic failure and upset failure. A catastrophic failure destroys the component beyond use. An upset failure damages the component so that it does not perform well, even though it may still function to some degree. Upset failures are more difficult to detect because they're not consistent and not easily observed. Both types of failures permanently affect the device. Now, to protect the computer against electrostatic discharge, always ground yourself before touching electronic components, including the hard drive, the motherboard, expansion cards, processors, and memory modules. You can ground yourself and the computer parts by using one or more of the following static control devices, or methods. A ground bracelet. Now, a ground bracelet, also called an anti-static wrist strap, or ESD bracelet, is a strap you wear around your wrist. The strap has a cord attached with an alligator clip on the other end. Attach the clip to the computer case you're working on, as shown here behind me. Now, any static electricity between you and the case is now discharged. Therefore, as you work inside the case, you will not damage the components with static electricity. The bracelet also contains a resistor that prevents electricity from harming you. Ground mats. Well, ground mats dissipate the ESD and are commonly used by bench technicians, also called a depot technician, that we covered in earlier chapters. Now, these guys repair and assemble computers at their workbenches or in the assembly line. Ground mats have a connector in one corner that you can use to connect the mat to the ground, as you can see behind me. And if you lift a component off the mat, it is no longer grounded and is then susceptible to electrostatic discharge. So it's important to use a ground bracelet with a ground mat. Static shielding bags. New components come shipped in these static shielding bags, also called anti-static bags. Now, these bags are a type of Faraday cage, named after Michael Faraday, who built the first cage in 1836. Now, a Faraday cage is a device that protects against electromagnetic fields. Save the bags to store other devices that are not currently installed in your PC. You should always have a little toolkit with extra and spare bags. To say you pull memory out of someone's computer, you don't want to throw it away. You want to store it in that bag while you're servicing the machine. As you work on a computer, know that the device is not protected from ESD if you place it on top of the bag. The protection is inside the bag. Anti-static gloves. You can purchase anti-static gloves designed to prevent an ESD charge between you and the device as you pick it up and handle it. Now, the gloves can be substituted for an anti-static bracelet and are good for moving, packing, or unpacking sensitive equipment. However, they tend to get in the way when working inside computer cases. And the best way to guard against ESD is to use a ground bracelet together with a ground mat. Consider a ground bracelet essential equipment when working on a computer. However, if you're in a situation in which you must work without one, touch the computer case or the power supply before you touch a component. When passing a circuit board, memory module, or other sensitive components to another person, ground yourself and then touch the other person before you pass the component. Leave the components inside the protective bags until you're ready to use them. Work on hard floors, not carpet, or use anti-static spray on the carpets. Generally, don't work on a computer if you or the computer have just come in from the cold, because there's more danger of ESD when the atmosphere is cold and dry. With ATX and BTX cases, know that residual power is still on even when the power switch on the rear of the case is turned off. Some motherboards even have a small light inside the case to remind you of this fact and to warn you that the power is still getting to the system. For this reason, when working on ATX or BTX systems, be certain to unplug the power cord and then press the power button to completely drain the power supply. Now, I don't mean just press it one time. Hold the button in for like 10 seconds and you'll be able to then drain the capacitors. Only then would it be safe to work inside the computer case. Protect against electromagnetic interference. Another phenomenon that can cause electrical problems with computers is electromagnetic interference, or EMI. It is caused by the magnetic field produced as a side effect when electricity flows through a cable. EMI in the radio frequency range is called radio frequency interference. Now, CRT monitors and older CRT televisions contain electronic magnets that can emit EMI. Other devices that are known to emit EMI, RFI, are PDAs, cell phones, cordless phones, microwave ovens, magnets, laser printers, power supplies, fluorescent lighting, AC adapters, bug zappers. I don't know why you'd be hanging on a bug zapper, but bug zappers. Okay, and other electric and electronic devices. EMI and RFI are reduced in these devices by using an EMI or RFI shielding, which is a type of Faraday cage inside the device. Now, this shielding might be a second layer of housing inside a device, but is more commonly done with a chemical coating on the inside of the device housing. Now, this chemical coating might be made of an acrylic compound, nickel, silver, or copper, and is sprayed or brushed onto the inside of the housing. Many electronic devices are affected by EMI and RFI, including computers, CRT monitors, and data cables. Now, if a CRT monitor flickers occasionally, try moving it to a new location, away from fluorescent lighting or a laser printer, or turn them off. If the problem goes away or lessens, suspect that EMI or RFI is the cause. For laser printers, you can check with the manufacturer for instructions how to verify that the RFI shield inside the printer has been properly installed. Data and data cables that cross an electromagnetic field or that run parallel with power cables can become corrupted by EMI and RFI, causing what we call crosstalk. Now, crosstalk can be partially controlled by using data cables covered with a protective material. These cables are called shielded cables. Now, one thing you can do to prevent crosstalk is to use only shielded data cables, but that's expensive and not practical. However, shielded cables are more expensive. Also, you might need to reroute data cables so that they're not running parallel to power cables or alongside the fluorescent lighting. If mysterious intermittent errors persist on a PC, one thing to suspect is the EMI or RFI. Try moving the PC to a new location, and if that problem continues, try moving it to a location that uses an entirely different electrical circuit. Move the PC away from any suspected device to eliminate it as a source. Simple way to detect EMI is to use an inexpensive AM radio. Turn the tuning dial away from a station and all the way down into a low frequency range. With the radio on, you can hear the static that EMI produces. Try putting the radio next to several electronic devices to detect the EMI that they emit. If EMI in the electrical circuit coming to the PC causes a significant problem, you can use something called a line conditioner to filter the electrical noise that causes the EMI. Line conditioners are discussed later on.